Hello, and welcome. Right now, as you settle in, as you begin to let go of the day, something is happening. Far away in the deep void, a clock is ticking. This isn't a clock of gears and hands, but one of distance and time, and it is ticking down to a deadline. A mystery that has presented itself to us, a visitor from the black ocean between the stars, is already on its way out. By early 2026, it will be too far away to see clearly. The window to solve its puzzle is closing. We are in a quiet race against the cosmos, and the puzzle is one that challenges everything we thought we knew about the cold, silent dark. The object at the heart of this mystery is named 3I Atlas. It is only the third interstellar visitor we have ever confirmed. The I in its name stands for interstellar. It is a designation that separates it from everything else in our cosmic neighborhood. It is not from here. It does not belong to our sun. Like Oumuamua and Borisov before it, this object is a messenger, a piece of another solar system sent tumbling through the dark for millions, perhaps billions of years before it happened to drift through our own. But this messenger is not silent. It is not a cold dead rock. This is the heart of the mystery. This is what has astronomers baffled, staring at their data and rechecking their models. 3 Atlas is spraying water into space. Not a small amount, not a subtle wisp of gas. The calculations show it is ejecting 40 kilograms of water every single second. Imagine that. 40 kilograms is a heavy suitcase, it's a large bag of cement. It is a significant tangible amount of mass. Now imagine that much water being shot into the vacuum every second of every minute of every hour. It is a geyser, an impossible fountain in the middle of the void. And here is the paradox. Here is why this clock is ticking so loudly. This geyser should not exist. We need to talk about where 3R Atlas is and just how cold it is out there. The object is currently moving through our solar system at a distance of roughly 3 astronomical units from our sun. That means it is 3 times farther from the sun than we are. It is in the region beyond Mars, drifting toward the asteroid belt. At that distance, the sun is not a warming, life-giving star. It is a small, bright point of light. The temperature of an object in that region is not just cold, it is a profound, penetrating cold. We are talking about temperatures around minus 180 degrees Celsius. At minus 180 degrees, water ice is not the ice you put in a drink. It is not snow, it is a rock. It is as hard and as stable as granite. For water ice to turn directly into a gas, a process we call sublimation, it needs energy. It needs warmth. That is what comets from our own solar system do. They are dirty snowballs that fall toward the sun, and as they get close, much closer than 3I Atlas is, now the sun's heat boils the ice, creating the beautiful tail we see. But 3I Atlas is too far, it is too cold, the ice on its surface should be completely inert. It should be frozen solid, locked in a state of suspended animation as it has been for eons. It should be a dead silent rock, and yet the geyser flows 40 kilograms per second. The discovery was made using the Swift telescope. Swift is an orbiting observatory, and when its instruments were pointed at 3I Atlas, the data that came back was unambiguous. The science community was, to put it mildly, confused. The data was clear, but it made no sense. How can you have a fountain of water in a place where water is, by all laws of physics, a solid stone? This is where the story gets tidy. Science does not like a vacuum, it does not like an unsolved puzzle, and so an explanation was put forward. The official explanation, the one that is currently being debated, is that we are not seeing a geyser. We are not seeing water boiling. Instead, the idea is that the object is shedding tiny microscopic grains of ice. The theory goes that billions of tiny ice particles, perhaps the size of dust, are being lifted from the surface and pushed away by the very gentle but constant pressure of sunlight itself. These tiny grains, once in space, would then slowly turn to gas, and this is what the Swift telescope detected. It is a plausible explanation. It uses known physics. It paints a picture of a cold activity that doesn't require the impossible heat of a boiling geyser, and yet it feels convenient, it feels small. It feels like an attempt to fit a truly strange observation into a box we already understand. The amount of water, 40 kilograms per second, is so enormous that it strains even this dust grain model. It asks us to believe that this object, for whatever reason, is constructed in such a precise way as to shed just the right amount of microscopic ice to fool us into seeing a geyser. As we lie here contemplating this visitor, we are left with a simple, profound doubt. Is this official explanation the truth? Is it just a strange dusty comet from another star behaving in a way we hadn't predicted? Or are we missing something? Is the clock ticking down on a discovery far stranger than a simple cloud of ice dust? Is there a process happening on this object, a source of energy that we simply do not understand. The object is on its way out. The 2026 deadline approaches, and the impossible geyser continues to flow a 40 kilogram per second question broadcast into the silent frozen dark. When an object travels from the cold outer darkness and draws near our sun, it begins to warm. The ice that has been frozen solid for millions or billions of years finally feels a new energy. This ice does not melt into water. In the vacuum of space, it turns directly into gas. This process is called sublimation. This cloud of gas, this temporary atmosphere, is called a coma. It is the bright fuzzy halo you see around a comet. And this halo is a gift, because as the light from our sun shines through that cloud of gas, we can read it. We can see which colours of light are absorbed and which are allowed to pass. This is called spectroscopy. It is a way of seeing the invisible. It is how we discover the chemical fingerprint of an object miles away travelling thousands of miles per hour. It is how we can taste the air of another world. When Oumuamua passed us, we turned our great telescopes toward it, desperate to read this fingerprint. We were hoping to find a familiar signature. We expected to find water. Water is the key ingredient of comets in our solar system. They are essentially dirty snowballs. We expected to see the chemical signature of home. That is not what we found. The data that came back was wrong. It didn't make sense. Our comets are overwhelmingly made of water ice, but this object was dry. The telescopes tasted its halo and found shockingly 8 parts carbon dioxide for every 1 part water. 8 to 1. This ratio is completely alien to our solar system. We have nothing like it. It is a Dalvante, a fingerprint from a place we have never seen, a system that must have been born in a completely different way than our own. Think about what this means. In our solar system, water ice is common, but in the system that Oumuamua came from, carbon dioxide ice must have been the dominant ingredient. This object was not a dirty snowball, it was a dirty, dry iceberg. This suggests it was born in a place that was incredibly rich in carbon, a carbon-rich system. Perhaps it orbited a star very different from our sun. A cooler star, maybe a red dwarf where the chemistry of planet formation is turned on its head. In our system, the frost line, the place where it's cold enough for water to freeze, is relatively far out. In this other system, perhaps the frost line for carbon dioxide was the most important one. This object was a chemical messenger, and its message was clear. The galaxy is infinitely more varied than we have ever dreamed. The way we formed the rules we followed may not be the standard, they may be the exception. This chemical strangeness was the first deep mystery, but it would soon be overshadowed by a second, far more profound paradox. A paradox not of chemistry, but of time. We are very good at tracking things. By measuring the precise path of Oumuamua, by seeing how the gravity of our sun bent its trajectory, we could rewind its journey. We could trace its path backward out of our solar system and into the dark expanse of the Milky Way. And by understanding its trajectory, its speed, and its chemical makeup, we could estimate its age. Our sun, our Earth, our entire solar system, we are about 4.5 billion years old. We are in our comfortable middle age. The calculations for Oumuamua, they told a different story. This object was not young, it was not middle-aged, it was ancient. The estimates placed its age between 7 and perhaps 10 billion years old. Let that sink in. 10 billion years old. That is more than 3 billion years older than our own sun. This traveller began its journey when our solar system was nothing but a cold, unformed cloud of gas and dust. It was born in an era of the galaxy we can only dimly imagine. It is a relic, a time capsule from a version of the universe that is now long gone. And this is where the mystery becomes a true impossibility. An object that has been drifting through interstellar space for 7, 8 or 10 billion years, should not be active. It should be dead. The void between the stars is not gentle. It is a harsh, unforgiving environment. For billions of years, this object would have been bombarded by cosmic rays, high-energy particles, travelling at nearly the speed of light. This constant radiation should have shattered its chemical bonds, breaking down the fragile ice. It would have been struck by countless micrometeorites, and most of all, the faint cold starlight of the galaxy should have slowly, relentlessly cooked away any volatile gases. A comet is like an ice cube left in the sun. It can only sublimate for so long before it is gone. A comet that has been travelling for 10 billion years should have exhausted all of its frozen gas eons ago. It should be nothing more than a kivotratrui, a barren husk, an inert dead rock, silent and cold. But Oumuamua was not silent, it was, as the scientists wrote, vigorously active. It was still outgassing. It was still releasing that cloud of carbon dioxide. After 10 billion years, it still had fuel to burn. It was this outgassing, this rocket engine of escaping gas that was causing it to accelerate away from our sun. How can a 10 billion year old traveller still be so full of life after an eternity in the deep freeze? What protected its fragile cargo? Why did it wait until it reached our solar system to suddenly and vigorously spring to life? This is the survival question, and it hangs in the air unanswered. It leaves us with only a few unsettling possibilities. Perhaps it was protected. Perhaps Oumuamua is not a comet at all. Perhaps it is the fragment of a much, much larger world. A world that was destroyed in some ancient cosmic catastrophe. What we are seeing is not the surface but the core. A dense protected heart that was shielded for billions of years by a thick mantle of rock. A mantle that was shattered and stripped away, leaving the core exposed. And only now, as it passed our sun, did this ancient heart finally begin to thaw. Or perhaps it is not what we think it is. This is the thought that is hard to voice but impossible to ignore. That the activity was not a random natural thawing, that the vigorous gas release was not accidental. That it survived its 10 billion year journey because it was built to survive. That it was protected not by a shell of rock but by a shell of technology. That it is not a barren husk because it was never just a rock. We are left staring at the chemical fingerprint of a carbon-rich world, a world 3 billion years our senior, that is behaving in a way that physics as we know it says should be impossible. The paradox of its age and the paradox of its activity points to one simple, terrifying, or perhaps wonderful conclusion: we are missing something. And that missing piece, that unknown, leads us to the third and most famous anomaly of all: the way it moved. The true challenge of the cosmos is not its scale, but its summonness and its darkness. When this new visitor, this traveller from the void, first entered the distant edges of our solar system, it was almost impossibly faint. It was a whisper, a ghost of a ghost moving against the tapestry of fixed stars. To even see it to confirm it was there was a triumph of engineering and sheer human persistence. Think for a moment about the Mars Express. This is a spacecraft that has been orbiting the red planet for decades. Its job is to look down to map the canyons and dried riverbeds of Mars. It was never designed to be an interstellar watchdog, yet with careful planning and a deep breath, engineers on Earth swiveled the entire spacecraft. They pointed its sensitive cameras away from the planet it knows so well and aimed it into the black, empty gulf of space. They were hunting for a shadow, and they found it. The image they captured is not something you would frame on your wall. It is a smear, a collection of just a few pale pixels against a noisy background. But in those few pixels, a story was written. It was proof. This faint traveller was real, and it was close enough to be seen by our own robotic emissary. We had for a second time caught a guest in our home. That faint smear of light was all we needed to chart its course, and the path it drew across our sky was definitive. In our solar system, everything is on a leash. The Earth, Mars, Jupiter, even the most distant comets, they are all bound by the sun's immense gravity. They travel in great looping ellipses destined to return again and again, even if their journey takes thousands of years. Their paths are closed circles. This object was not on a leash. Its trajectory was what astronomers call a hyperbolic orbit. It is the mathematical signature of a visitor. It means the object came in fast, screaming towards our sun from an unknown origin. It is now looping around our star, using its gravity like a slingshot, and it will be thrown back out into the deep, never to return. It is not bound to us. It does not belong to our family of planets. It is unequivocally an interstellar traveller. This realization sends a familiar shiver down the spine of the scientific community, because we have been here before. The ghost of Oumuamua hangs over this entire discovery. Back in 2017, we were graced with our first confirmed visitor. We named it Oumuamua, a beautiful Hawaiian word meaning a messenger from afar arriving first. It was a puzzle from the moment we saw it. It was small, shaped perhaps like a cigar or a flat pancake, and it was tumbling end over end. But that was not the strange part. The mystery of Oumuamua was its motion. As it looped the sun and began its journey back out into the void, it sped up. It accelerated. Now we know things that do this. Comets do this. As a comet gets near the sun, its ice warms up and bursts forth as gas. This outgassing acts like a tiny natural rocket engine, pushing the comet and changing its speed. But when we looked at Oumuamua with our most powerful telescopes, we saw nothing. There was no gas cloud, no dusty tail, no coma. It was accelerating without a visible engine. This anomaly, this contradiction, opened the door to a profound and deeply uncomfortable idea. The astronomer Avi Loeb from Harvard University put forth a hypothesis that stunned the world. He suggested that the only thing that fit the data was something artificial. He proposed that Oumuamua was a light sail, a thin, vast reflective sheet designed to be pushed by the pressure of starlight itself. It is a technology that our own civilization is dreaming of building for interstellar travel. The idea was and remains deeply controversial. Science prefers the natural explanation, but the problem is that the natural explanations for Oumuamua simply don't fit the facts very well. It remains a deep, unsettling riddle. It was a messenger that whispered a secret as it flew past and we couldn't understand the language. It was gone too fast. We didn't have the tools, but this time is different. The arrival of this new visitor, the one Mars Express strained to see, has happened in a new era of astronomy. We now have the James Webb Space Telescope. This magnificent golden eye floating 1 million miles from Earth has abilities we could only dream of in 2017, and we pointed it directly at this new traveller. What it found moves this story from simple curiosity to something far more profound. The James Webb Space Telescope didn't just take a picture, it performed spectroscopy. It caught the faint sunlight that was reflecting off the object's surface and broke it down into a barcode of light. This barcode reveals its chemical composition, and what it found was breathtaking. The object is rich in organic molecules, not life, but the building blocks of it. Carbon-based compounds, complex molecules, the very ingredients of prebiotic chemistry. It is confirmation that the raw materials for life are not unique to our solar system. They are drifting in the dark between the stars, just waiting for a safe harbour, a warm planet. This alone is a revolutionary discovery. But the telescope found something else. It found a new anomaly. The ratios of these molecules, the specific mix of these organic compounds, they are different. They don't match the chemical fingerprints of the comets born in our own solar system. They don't quite match our models of what a comet formed around another star should look like. The barcode is strange. It's a signature we don't recognise. And so we find ourselves at a quiet philosophical crossroads. The ghost of Oumuamua is here reminding us of acceleration without an engine. And now this new object arrives, not only confirming that the building blocks of life are interstellar, but presenting them in a package we don't understand. This is where we must ask the uncomfortable question, the one that shifts us from awestruck stargazers to true scientific skeptics. What if it is artificial? This question is not a leap to ancient aliens or fantasy. It is the very essence of legitimate scientific inquiry. Science demands that we test the null hypothesis. The default assumption is that this object is entirely natural, a comet, an asteroid, a fragment of a long-dead planet from another star. We must try with all our effort to make the data fit that assumption. But what if it doesn't fit? When the data is anomalous, skepticism must flow in all directions. We must be as skeptical of the natural explanation as we are of the extraordinary one. Oumuamua's acceleration was an anomaly. These new organic ratios are an anomaly. So let us just for a moment seriously consider the alternative. If this were a piece of technology, a probe, a ship, even the discarded refuse of a civilization, what would it look like after drifting in the cold radioactive dark for millions, perhaps billions of years? It would be battered by micrometeors. Its surfaces would be chemically altered by cosmic rays. It would almost certainly be dead. It would collect a layer of interstellar dust and ice masking its true nature. It might look for all the world like a comet, but perhaps deep inside or integrated into its very structure would be materials and chemical combinations that nature would not produce. Would a decaying power source or a fragment of an alien computer or a long-dead life support system create a chemical signature that our telescopes would register as different? We are no longer in the realm of science fiction. We are in the realm of data. We have an object that came from another star. It is made of the building blocks of life, but in proportions we have never seen. And it follows a predecessor that moved in a way we cannot explain. These visitors, these ghosts from the dark, are forcing our hand. They are challenging our most fundamental assumption that we are alone. They are forcing us to confront the possibility that the universe has not only produced life elsewhere, but that it has produced technology. This new guest will soon be gone like Oumuamua before it. It will flee our system, carrying its secrets back into the infinite night. We only have this brief moment, this fleeting window to listen to what it has to say. As you lie here balanced on the edge of awareness, let your mind drift with it. Feel the cold of interstellar space, the immense patient journey, the silence of ages. We are a tiny, noisy island in a vast, quiet ocean, and for the second time in our history, a message in a bottle has washed ashore. We are staring at the bottle, unable to read the script, wondering who or what threw it into the sea. The universe is whispering. The question is no longer if we are listening, but if we are brave enough to understand what we might be hearing. Sleep now, let the mystery hold you, the stars are waiting. But as we rest here drifting in the quiet of our minds, let us look closer at this distant traveller. When you observe something for long enough, the familiar details begin to fade and new stranger details emerge from the static. At first, we saw what we expected to see. A comet. A faint, blurry visitor from the cold and distant darkness. We were comfortable with this idea. It fit our models, it fit our understanding of the cosmos. But the data kept coming. Cold, hard numbers transmitted across the void from our telescopes, our most sensitive instruments, and these numbers began to tell a different story. Not a story of a simple tumbling piece of ice and rock. It began with a whisper, a single data point that seemed wrong, an anomaly. Scientists are used to this. An anomaly is usually just noise and error in the instrument or a brief unexplained flicker. You note it and you move on. But then another whisper and another. The whispers began to join, forming a quiet, insistent chorus, a question that hung in the silence. And the question was, are you sure you know what you are looking at? This is the weight of the anomalies. The first one was the spin, its rotation. We know what comets look like. We've seen them. They are not perfect spheres, they are lumpy potato-shaped chaotic objects. When the sun warms them, they don't just glow, they vent. Jets of gas and dust erupt from their surface, not smoothly, but in fits and starts from cracks and fissures. These jets act like tiny random rockets pushing the comet. A jet fires here, it tumbles one way. A jet fires there, it spins another. The result is what we call a chaotic tumble. It is messy. It is unpredictable. It is natural. It is the beautiful chaos of nature. This object, however, is not chaotic. It spins, and its spin is stable. It turns on its axis with a regularity, a stability that is almost mechanical. It's like the difference between watching a falling leaf caught in the wind tumbling unpredictably on its way to the ground, and watching a gyroscope spinning perfectly on its point stable and true. The data shows a spin that is clean, consistent, almost unwavering. The forces of outgassing, which should be sending it into a chaotic tumble, seem to have no effect. Or perhaps the outgassing itself is not what we think it is. This stability is the first whisper. It's too tidy, too clean. It's a piece of data that sits awkwardly refusing to fit the puzzle. And then came the second whisper, the matter of its energy, its warmth. These objects born in the outer darkness are ancient, billions of years old. They are the frozen leftovers of the solar system's birth. They have been in the deep cold for so long, they should be cold all the way through. They have a tiny bit of internal heat left over from their formation and from the slow decay of radioactive elements trapped inside them, but this is a tiny, tiny amount of warmth. And for an object this old and this small, that internal battery should have died long, long ago. It should be inert, dead, a cold, frozen heart. Its only source of warmth should be the distant sun. We can calculate this. We know how much sunlight is hitting it, and we know what a simple piece of rock and ice should radiate back into space. But this object, it seems to be emitting just a little bit more heat than it should. It's a tiny discrepancy, barely measurable, but it is persistent. It is as if something deep inside is still warm, but that is impossible. The radioactive decay models are clear. An object of this size and age cannot still be generating its own heat. That well should be dry. So where is the energy coming from? It's like finding a small stone on a frozen lake hours after sunset in the dead of winter, and finding it is still warm to the touch. You would stop, you would wonder, what is heating this stone? This is the second whisper. A tiny, unexplained warmth radiating out into the cold. A battery that should be dead but still shows a faint, inexplicable charge. When scientists are faced with the 2, 3 or 4 such anomalies, they are forced to do something that is both deeply scientific and profoundly human. They are forced to imagine. They must step outside the comfortable box of known explanations. They must allow themselves to entertain a thought experiment, a hypothesis that just yesterday might have seemed like wild speculation, or even science fiction. Let us join them just for a moment in this thought experiment. What if this object is not a comet at all? What if it is disguised as a comet? Imagine a highly advanced civilization billions of years old. They wish to send a probe and explorer across the galaxy. They want it to travel perhaps for millions of years unseen. They want it to be patient. They want it to survive. How would they build it? They wouldn't build it from shining, polished metal. That's a beacon. That's a target. It screams artificial. No, they would build it to blend in. They would use the universe's own camouflage. They would build it to look like one of the countless boring natural objects that drift between the stars. They would disguise it as a comet or a dead asteroid. A dark, quiet, tumbling piece of rock and ice. It would be an artificial probe, a machine of incredible complexity, hidden inside the shell of a common comet. It's an extraordinary thought, a breathtaking one, and one we would dismiss instantly, except for that insistent chorus of whispers. Because suddenly, if we hold this thought, this idea of a camouflage probe, the other anomalies, the other whispers don't just get louder, they begin to make a terrifying kind of sense. Let's think about that spin again, that almost mechanical stability. If this were a probe, it would not be tumbling. It would have a navigation system. It would need to be stable to keep its instruments pointed, to keep its antenna aimed. The jets we see might not be chaotic natural vents at all. They might be thrusters, small precise controlled engines firing with perfect calibration to maintain the object's stability to guide its path. They would fire just enough to counteract any natural tumbling. They would create a nearly mechanical spin. This idea, this thruster hypothesis, leads us to the third and fourth anomalies, the ones that are perhaps the most powerful of all, the carbon dioxide paradox and the distribution of organics. Our newest, most powerful eye in the sky, the James Webb Space Telescope, has looked at this object. It is designed to see in the infrared, to see the faint heat signatures of molecules. We pointed it at this traveller expecting to see the cloud of gas around it, and we found puzzle. The object appears to be very rich in carbon dioxide, but when the Webb telescope looked, the signal for carbon dioxide was not blazing as it should have been. It was muted. Strangely, the signal for water seemed more prominent. It was as if the object was preferentially releasing water but holding back its carbon dioxide. This makes no sense for a natural comet. Sublimation. The process of ice turning directly to gas is simple. The sun heats the ice and all the ices boil off together based on their temperature. Carbon dioxide ice boils off more easily than water ice. We should see tons of it, but we don't. The signals are scrambled. But if it's a probe and the jets are engines, then what we are seeing is not natural sublimation. We are seeing exhaust. The machine is choosing what to release. Perhaps it uses water for one kind of maneuver and carbon dioxide for another. Or perhaps it is using a complex engine system that breaks down molecules and releases them in ratios that have nothing to do with nature. The machine isn't boiling, it is venting with purpose. And this leads to the organics, the building blocks of life. In a natural comet, these complex organic molecules are mixed in randomly. They are ancient primordial ingredients frozen into the ice like fruit scattered randomly through a fruitcake. But when we look at this object, the organics don't seem to be random, they seem organized. They appear in specific places, perhaps concentrated near those very same jets or thrusters. This is the fourth whisper, a strategic distribution. If it's a probe, these molecules are not just random ingredients. They could be fuel, a specific complex chemical propellant carefully stored and routed to the engines. Or perhaps it's a shielding material, or perhaps it is cargo. The arrangement isn't random because it wasn't formed randomly, it was placed, it was engineered. The pattern continues. The fifth anomaly, the dust. When we look at the dust cloud, the Comet that surrounds this object, we find something that breaks a fundamental law of nature. When a rock shatters, or when a piece of ice fragments, it follows a simple, predictable rule. You get a few very large pieces and a lot of very, very fine dust. You get very few pieces in the medium size range. This is a law of fragmentation. It's true for asteroids, it's true for comets, it's true if you smash a rock with a hammer. You get boulders and you get sand, you don't get a perfect neat pile of just gravel. The dust cloud around this object is a perfect neat pile of gravel. It has far, far too many medium-sized dust grains. It defies the natural fragmentation law. The dust it is shedding is not the dust of a natural object breaking apart. It is something else. If it's a probe, what could this be? Perhaps the outer camouflage layer is an engineered material, a form of ablative shielding designed to wear away in a controlled, predictable manner. It doesn't shatter like rock, it flakes, and the flakes it produces are of a uniform medium size. It's the dust not of a rock, but of a product, a material manufactured to have specific properties. And finally, the sixth anomaly, the most ethereal, and perhaps the most telling. The coma itself, the halo of dust and gas around the object. We have models, We know how the solar wind and the pressure of sunlight should affect this cloud. These are powerful constant forces. They should blow this faint halo away like smoke in a strong breeze. The structures we see in the coma, the jets, the fans should be fleeting. They should appear and then be distorted and blown away by the solar wind within hours or at most a day. But they are not. The structures we observe are durable. They are stubborn. They hold their shape for days, sometimes weeks, defying the models, defying the power of the sun. They exist far longer than they have any right to. It's as if something is holding them. What could hold dust and gas together in the vacuum of space? What could resist the constant, powerful solar wind, an invisible force? A magnetic field. A natural comet, a simple piece of ice and rock, is not magnetic. It has no internal dynamo. It is at the mercy of the solar wind. But a machine, a probe, a spacecraft, it would almost certainly have a magnetic field. It might be a byproduct of its power source. A fusion reactor, perhaps, or it might be a deliberate powerful shield projected to protect the probe from radiation and cosmic rays. And this field, this invisible bubble of force, would trap the dust and gas. It would hold the exhaust from its thrusters, shaping it, guiding it, creating structures that persist, structures that laugh at the solar wind. The durable coma is the sixth whisper. It is perhaps the signature of an engine, the shadow of a shield. One anomaly is a curiosity, two a coincidence, but six anomalies all pointing in the same impossible direction. The weight of these things is immense. It is the weight of a possibility that could change our understanding of everything. The stable spin of a gyroscope, the unexplained warmth of a living thing, the controlled exhaust of an engine, the organized strategic placement of fuel, the uniform manufactured dust of an artificial skin, and the magnetic grip of an invisible shield. These are the whispers that have become a chorus. They force us to lift our gaze from the comfortable and the known. They force us to contemplate a universe that is not just empty, but perhaps occupied. A universe that is not just filled with silent natural wonders, but with the quiet, patient, and impossibly old works of others. And as we rest here in the dark, in the silence, the question hangs in the void, a new and heavy weight. We are looking out, but what if something for a very, very long time has been looking back? The final months of 2025 arrive with a tension the entire world can feel. It is no longer an abstract astronomical curiosity. The object, our silent visitor, is now an active participant in our sky, a traveller making it in a final dramatic turn. It is accelerating to an incredible speed, falling toward the sun on a path that will take it closer than the orbit of Mercury. This is the moment, this is the deadline. In the long, cold nights of December, it reaches perihelion, its closest, fastest, and most violent encounter with our star. The object is moving at hundreds of kilometers every second, a blur of cosmic potential. For a few short weeks, as it endures the full blistering force of the sun and then swings back out, we will have our last and best chance to see it. This is not an observation, this is an interrogation. To conduct it, humanity has assembled the single greatest observational campaign in its history. This is not one telescope looking, this is an entire planet. Every major observatory on Earth and in space pivots to stare at this one fleeting point of light, the James Webb Space Telescope. Golden Eye in the dark is the star of the show. Its massive mirror, designed to see the faint heat of the first galaxies, is now pointed at something much closer. It is looking for heat, yes, but not just the reflected heat of the sun. It is looking for anomalous heat. Is the object warming up evenly like a simple rock, or are there hotspots? Is there a power source, a drive, an engine, an interior that is against all logic warm? At the same time, the Hubble Space Telescope, our faithful servant for decades, provides the sharpest possible view in visible and ultraviolet light. It is searching for any gases, any plume of material, any tail, however faint, that the sun's radiation might be kicking off its surface. On the ground, the great observatories of Earth join the hunt. In the clear, dry air of the Atacama Desert in Chile, the Very Large Telescope and the ALMA radio array work in unison. The VLT uses its giant mirrors to taste the light, breaking it apart with spectrographs. This is not just about seeing, it's about knowing. Is the light reflecting off simple rock off ice, or is it reflecting off something else? Something like titanium or ceramic or a polished artificial surface? ALMA, meanwhile, isn't looking, it is listening. It is listening for the faintest millimeter wave radio signals, whether they are the natural crackle of excited molecules or something far more structured. All around the world, other radio telescopes, from the quiet arrays of SETI to major government dishes, have abandoned their other projects. They are all listening to the same tiny patch of sky waiting for a whisper. This global network is working around the clock. As the Earth turns, one observatory sets while another rises, passing the baton in a relentless 24-hour-a-day vigil. The data flows in measured not in gigabytes but in petabytes, a torrent of information that computers are sifting through in real time. All of this effort, all of this technology is focused on answering one question. And as the object makes its fiery pass and begins to climb away from the sun in the first days of 2026, the data points coalesce. The teams work frantically checking and rechecking their models, and as they do, the future splits. The answer they find is not one answer, but three. Three possible kitsch-ban, three new realities for humanity to face. Scenario 1. The natural explanation. In the first scenario, the most likely and the most rational science provides a difficult but complete answer. The perihelion is a violent event. As the object is blasted by unimaginable levels of solar radiation, its surface, which has been frozen for millions, or perhaps billions of years, finally reacts. The James Webb Space Telescope sees it heat up, and it heats up exactly as the models predict a large, dark, rocky object would. There are no strange hotspots, no hidden engines. It is a cold, dead piece of matter momentarily lit by a star. Then the ground-based telescopes get the data they were waiting for. As the surface temperature climbs to hundreds of degrees, the object does begin to outgas. A faint weak tail appears, but Hubble's sharp eye sees that it isn't a normal comet's tail. It is not made of water ice. The spectrographs in Chile get a clear reading. The gas is a strange mixture of exotic ices, things like frozen nitrogen and methane, but mixed with metallic dust particles that are rich in heavy elements, elements that are rare in our own solar system but perhaps common in the star system. This object called home. What about its strange tumbling rotation? As the sun's heat blasts it, these newly opened vents of gas act like tiny random rocket thrusters. The outgassing is uneven, and this uneven force causes the object to shift and steady. Its strange tumble smooths out into a more stable, predictable spin. The scientific community, after weeks of frantic debate, comes to a consensus. It is not a probe, it is not an artifact. It is a comet. It is without question the strangest, most alien comet we have ever seen. It is a refugee from an ancient, distant solar system, a system so different from our own that it forged its planets and comets from a different recipe of stardust. It has taught us that the universe is more diverse, more varied than we ever imagined. But it is in the end natural. The world breathes a collective sigh. For some, it is a sigh of relief. The universe is still a familiar if vast place in ways. For others, it is a sigh of disappointment. The great silent hope for a sign for proof that we are not alone has faded. The visitor was just a rock. A fascinating rock, one that will launch 1,000 new scientific papers and force us to rewrite our models of planet formation, but a rock nonetheless. The mystery is solved, and the object, now just an astronomical catalogue number, coasts back into the darkness, leaving us behind. Scenario 2. The mystery persists. In the second scenario, the data that flows in from the global campaign does not solve the mystery. It deepens it. The perihelion pass happens, the object endures the fire, and it gives us ambiguity. The James Webb Telescope sees the object heat up, but the data is noisy. The thermal models don't fit. Some parts of the object seem to absorb the sun's heat, while other parts seem to reflect it in a way that defies physics. It is almost as if it is managing its own temperature, but the readings are just on the edge of the margin of error. It is impossible to be certain. Does it outgas? Yes. And no. Hubble sees a faint, indistinct coma, a cloud of material around it, but the spectrographs on the ground cannot get a clear reading. The chemical signatures are contradictory. One telescope registers hydrogen, another registers nothing. One team claims to see the spectral lines of complex metals, another team proves their data is flawed. What about its movement? As it swings around the sun, its trajectory is almost perfect, but not quite. It deviates from the expected path by a few dozen meters. Is this the push from a hidden subtle engine, or is it the effect of that faint invisible outgassing that we cannot properly measure? The object leaves, it flies away from the sun back into the void, and we are left with nothing. We have no clear answers. The data is too vague, too strange, too full of contradictions. The scientific community fractures. One camp insists it must be natural. They argue that we have simply witnessed a phenomenon we do not understand. They claim that the noisy data is just that noise, and that we are seeing patterns where none exist. The other camp insists the ambiguity is the answer. A natural object, they argue, would be simple. It would follow the rules. This object breaks the rules. The contradictory data, the subtle path change the weird thermal readings. They argue this is the signature of an advanced complex object that is hiding its true nature. But there is no proof, there is no smoking gun, there is no signal, no clear picture. The object becomes a cosmic ghost. It is a Rorschach test for humanity. Do you see a rock or do you see a ship? The debate rages for decades, becoming a permanent fixture of our culture. We are left in a state of profound and agonizing scientific uncertainty. We had our one chance to know, and the universe in its infinite complexity refused to give us a simple answer. The mystery is not solved, it simply becomes a permanent part of who we are. Scenario 3, the unthinkable. In the third scenario, the perihelion pass gives us an answer. It is not the answer we were prepared for. As the object reaches its closest point to the Sun, the global network is at its peak. And then it happens. The team at the ALMA radio observatory in Chile sees it first. For 3.7 seconds, a narrow tight beam radio signal bursts from the object. It is not static. It is not a natural pulsar. It is a complex structured mathematical signal. It is a burst of data shot from the object directly at somewhere else. Perhaps its home star. It is a diagnostic check, a status update. Perihelion achieved. System integrity at 98%. The signal is clear, undeniable, and utterly artificial. At the exact same moment, the James Webb Space Telescope registers a thermal anomaly. A single tiny point on the object's surface flashes heating up by thousands of degrees for just a fraction of a second the physical location of the transmitter. Or perhaps it's not a signal, perhaps it is a movement. As the object swings around the Sun, the teams tracking its orbit notice a discrepancy. It is not following a purely gravitational path. After it passes the Sun, its velocity increases by a tiny precise amount, just 9 meters per second. It is not a random push from outgassing. It is a clean, efficient burn, a deliberate course correction. It used our Sun's gravity, and then it added a tiny, precise push from its own engine, fine-tuning its trajectory for its next destination, perhaps another star thousands of years from now. The data is confirmed, the calculations are checked. There is no ambiguity, there is no margin of error. It is not a rock, it is not a comet, it is a probe. The information is leaked and the world is changed forever. We are not alone. The fact is no longer a matter of faith or statistics or hope. It is a matter of observation. We have for the first time in our history a piece of hard, undeniable evidence. The universe is populated. We are at best a new development. At worst, we are a roadside curiosity for a traveller just passing through. The discovery breaks humanity, and then perhaps it remakes it. The hard reality. But let us pause for a moment on that third dramatic scenario. Let us consider the true nature of such a discovery. Even if scenario 3 were the truth, the reality is that it would almost certainly look like scenario 2. Think about it. Any civilization with the technology to build an interstellar probe is by definition vastly more advanced than we are. And if they are advanced enough to build it, they are advanced enough to build it well. The first rule of observing a less developed world is you do not interfere. You do not announce yourself. You hide. That probe would be designed with one primary goal beyond its scientific mission stealth. It would be built to look like a dead, tumbling piece of rock. It would be coated in materials that absorb radar. It would be designed to vent heat in a way that mimics a natural object. That 3.7 second radio signal. It would have been a terrible mistake, a technical failure, and it would be so faint, so brief that most observatories would miss it. The team that did see it would be accused of having faulty equipment. Their data would be dismissed as an error, a glitch in the system. That 9 meter per second engine burn. It would be so subtle it would be mathematically indistinguishable from a puff of trapped gas escaping in a lucky direction. The scientists who argued it was a deliberate burn would be called sensationalists. The natural outgassing model would be the accepted rational explanation. This is the hard, cold reality of first contact. It would not be a fleet of ships arriving in orbit. It would be a single, ambiguous data point. We would be left even in the face of proof with only our suspicions. We might know in our hearts what we saw, but we could never prove it. The object would continue its journey into the darkness, and we would be left staring at the data forever changed, forever arguing, haunted by a truth that we could see but never ever grasp. For so long we have been looking inward. We have studied the sand beneath our feet, the clouds above our heads, and the planets that circle our own sun. We have built our models of the universe based on this single precious data point. our solar system. We have lived in a quiet room believing it was the whole house, and then the door opened. A visitor swept through, and then another, and another. We have spent our time looking closely at these travelers, these fragments of other worlds. We have marveled at their strangeness and their familiarity. But now it is time to do what we do as the night deepens. It is time to zoom out. It is time to pull the camera back from the close-up past our solar system, past our neighborhood, and to look at the grand sweeping picture of the galaxy that these visitors are painting for us. What does it all mean? Our first visitor. One eye. Oumuamua was a shock. It was the first. It was strange, shaped like nothing in our own system, moving in a way we could not easily explain. It was a riddle. It raised the terrifying possibility that we were the strange ones, and the galaxy was filled with objects we could not comprehend. Then, not long after, came Two-Eyed Borisov, and it was a profound comfort. It looked normal. It was a comet. It had ice. It had a tail of gas. It behaved exactly as a comet from our own Oort cloud would behave. It was a message of reassurance. It told us that our corner of the galaxy is not unique. It told us that the same processes that built our home are at work elsewhere. We are not the exception. We are part of the rule. But then our story introduces a third visitor. Let us call it Three-Iron Atlas, as you've suggested. And this one is not a comfort. It is not a simple rock, and it is not a simple comet. It is complex, fragmented. Perhaps it is a piece of a larger body, something that was shattered long ago. It is, as you said, very strange. This progression is the new foundation of our cosmic understanding. First the strange, then the normal, and then the very strange. If you pull 3 random samples from a vast ocean, and one is a strange rock, one is a familiar fish, and one is a complex, unknown organism, what have you learned? You have learned that the ocean is not one thing. You have learned that the ocean is endlessly, wildly, and profoundly diverse. This is the first truth these visitors give us. The universe is not standardized. The factory that builds solar systems does not have a single blueprint. We look at our own system and we see our pattern. Small rocky worlds close to the sun, giant gas planets farther out, and then a vast halo of icy comets. We assumed this was the standard model. We assumed this was how it was done. These visitors shatter that assumption. The existence of Oumuamua suggests some systems may be incredibly efficient at creating and ejecting dense, rocky, cigar-shaped objects. The existence of Borisov confirms that systems like ours with vast comet clouds are also common. And the existence of this hypothetical fragmented atlas suggests a third type of system. Perhaps one that is violent, chaotic, full of collisions, one that specializes in shattering its own worlds and casting the pieces into the void. Imagine a solar system with no rocky planets at all, just a chorus of gas giants in a tight looping dance. Imagine a system where 2 super-Earths orbit each other, sharing an atmosphere. Imagine a system that died long ago, orbiting the cold remnant of a white dwarf, its planets shattered into a billion atlas fragments. This is the canvas they paint. The galaxy is not a quiet place with identical copies of our home. It is a vibrant, chaotic, and creative laboratory. And the evidence for this diversity is no longer theoretical. It is flying directly through our backyard. This leads us to the second and perhaps more profound realization, the new statistical reality. For all of human history, the number of interstellar visitors we had confirmed was 0. They were purely theoretical. We assumed they were rare, moving too fast to see like invisible bullets in the dark. Then we built a better eye. A telescope called Pan-STARRS designed to scan the whole skies quickly. And almost immediately it found Oumuamua. The moment we looked, we found one. It's like living in a house believing you are totally alone. And one day you install a security camera and you discover that people have been walking silently down your hallways every single night. You just didn't have the technology to see them before. We are about to get even better technology. The Vera Rubin Observatory, for instance. When it comes online, it will scan the sky with such power and precision that we will no longer be finding one visitor every few years. Scientists predict we may find dozens, hundreds. We are standing on the shore of a new cosmic ocean, and the first few pieces of driftwood have just washed up. But we are about to witness the tide come in. In a decade, we may have a catalogue of thousands of these objects. We will know. It will be, which kind of interstellar comet is this? This is a fundamental shift in our reality. The solar system is not an island, it is a port. We are not isolated. We are part of a vast galactic ecosystem. We are constantly at this very moment flying through a sparse rain of material from other stars. We are breathing in away the dust of other worlds, and this inevitably brings us to that great haunting question, the one that echoes in the quiet of the night, the Fermi paradox. The paradox is simple. If the galaxy is old and vast and should be teeming with life, where is everybody? Why is the sky so silent? These visitors offer two different and contradictory answers. The first answer is a sobering one. If we are about to be flooded with thousands of natural objects, then the odds of any single object like Oumuamua being artificial drop to almost zero. Think of it this way. If you are walking in a vast desert and find a single perfect seashell, you might be tempted to believe someone placed it there for you. It's a sign, a message. But if you climb the next dune and discover you are standing on a beach that stretches for 1,000 miles, a beach covered in billions of seashells, you must abandon your first idea. You are not special. You have simply discovered a natural process. This new statistical reality suggests we are about to find the beach. Oumuamua may not have been a message. It may have been just the first seashell. This answer to the paradox is a lonely one. We are finding so much natural cosmic driftwood that it makes it less likely we will ever find a message in a bottle. The silence in this case is real. But there is a second answer, a counter-argument, a more thrilling and perhaps more chilling possibility. The statistical argument assumes that the visitors are random. It assumes that our solar system is just another patch of empty space, no different from any other. But what if it is not? What if our solar system is interesting? For over 2 billion years, our planet has been broadcasting a very specific, very loud signal into the galaxy. It is a chemical signal written in our atmosphere. The signal is oxygen. In an atmosphere, oxygen is an impossibly reactive, unstable gas. It should not be there. It must be constantly replenished. And the only thing we know that can do that on such a scale is life. Photosynthesis. Our pale blue dot has a biosignature. It is potentially a galactic landmark. Now think like an explorer. If you're exploring a vast dark ocean, do you cast your nets at random in the empty abyss? Or do you sail toward the places that show signs of life, the reefs, the plumes of activity? This is the counter-argument. Yes, the galaxy is likely filled with billions of random natural comets, but perhaps it is also filled with probes. And those probes are not wandering aimlessly, they are directed. They are sent with purpose to the interesting systems, to the stars that show the chemical signs of life. In this scenario, Oumuamua's arrival was not a coincidence. Its strange deceleration was not just gas. It was a probe aimed at our star, braking just enough to get a close look at the landmark planet, the one screaming life into the void. If this is true, the answer to the Fermi paradox is not that the galaxy is silent. It's that we are only just now realizing that the visitors are the message. And here, in the final moments of our contemplation, we find the most profound reflection of all. We find a mirror. We think of this idea interstellar probes targeted exploration as something alien, something from science fiction. But it is not. It is human. Right now, at this very moment, we are planning this. We humanity. A project called Breakthrough Starshot is developing a real tangible plan to send probes to our nearest neighbouring star, Proxima Centauri. The plan is not to send one giant ship. The plan is to send thousands of tiny nanocrafts, little sails pushed by a giant Earth-based laser accelerating them to 20% of the speed of light. We are designing today the very things we are looking for. And what would our probes do when they reach that distant star? They would fly through fast. They would aim for the planets in the habitable zone. They would gather data. They would be in every sense an interstellar visitor. So when we look up at an object like Oumuamua, what are we truly seeing? Are we seeing a strange rock from a distant natural process? Are we seeing the technology of a civilization 1 million years ahead of us? Or perhaps, are we just seeing ourselves? Are we seeing the logical endpoint of our own curiosity, our own ambition, reflected back at us from across the gulf of time and space? We thought the galaxy was seer, but it is not. It is whispering. It is sending us its dust, its comets, its fragments. And in them we see the diversity of all creation. We see the statistical probability of our own loneliness. And we see perhaps the echo of our own future. A future where we are not just the watchers on the shore, but the ones who finally set sail casting our own messages into the vast, dark and wondrous cosmic ocean. Sleep now, and as you drift, let your mind travel with them. Let it ride on the back of these silent travellers across the gulf to the shores of other worlds and to the quiet, infinite possibilities of the night. Right now, in this very moment, it is December 25. The world, for a brief, quiet instant, is holding its breath. We are watching, All of our greatest instruments, our human-made eyes on the sky, are pointed at one tiny, fast-moving spot near the heart of our solar system. The moment we have waited for the perihelion is happening. In silent control rooms and on remote mountaintops from the high deserts of Chile to the orbital platforms above our heads, the atmosphere is electric. The only sound is the gentle hum of computers, the quiet tapping of keys. The data is beginning to stream back. For years we tracked this visitor. We argued about it, wrote papers on it, dreamed about it. We knew this passage would be the ultimate test. Oumuamua is now closer to our sun than the planet Mercury. It is moving at hundreds of thousands of kilometers per hour, enveloped in the raw, unfiltered power of a star. What are we witnessing? The images from the Hubble Space Telescope are what we expected. Blurry, uncertain ghosts of light against the impossible glare of the sun. Oumuamua is just a smudge, a streak of motion. We cannot make out its shape, but we can see it, changing. The light reflecting from it is not steady. It is flashing, tumbling chaotically. The sun's immense gravity is pulling at it, and its heat is boiling its surface. It is a violent, beautiful dance. But the true story, the one that makes the heart stop, is coming from the James Webb Space Telescope. The JWST is not just seeing light, it is seeing heat, it is seeing chemistry. It sends us a spectrum, a rainbow of invisible infrared light, and it is a story written in fire. The heat, the sheer violent furnace of the sun, thousands of degrees hot, is doing exactly what we hoped. It is peeling back the outer layers of the traveller. The dark radiation-scorched crust, the carbon-rich material that has protected it for millions of years, is vaporizing. It is turning directly into gas, blasted away by the solar wind. We are watching the sun perform surgery, slicing away the surface to see what lies beneath. And as these layers vanish, the data floods our screens, and silence falls in the control rooms. The questions we had before, they seem so small now. They have been replaced by new ones, questions far deeper and stranger. The heat is not just destroying, it is revealing. Our first question: did the heat reveal a different structure inside? We expected to see the signature of rock, maybe some metal, like a simple asteroid. But the spectroscopic signature, the chemical fingerprint, it changed. For a few brief, critical minutes, as the outermost layer burned away, the light signature from beneath looked different. It was not just inert rock. The data screamed with complexity. We saw signatures that looked ordered, not random. Was there an internal structure, something shielded by the outer crust, now briefly exposed by the fire? We don't know. The moment passed. The signal is already fading as it moves away. Our second question: how did it break apart? We expected it to fragment, to shatter like a comet, or split into a dozen pieces. But the data doesn't show a clean break. It shows a shedding. It seems to be shedding its layers in a way that is almost controlled. Not a chaotic explosion, but a deliberate peeling, like an old skin being cast off. It holds its integrity. It remains one object, despite an assault that should have torn it to dust. Why did it not simply dissolve? How is it so resilient? And then the most profound question: the organic signals, the complex molecules we glimpsed before. As the heat intensified, we expected them to be destroyed, to be broken down into simple carbon and hydrogen atoms, and they were. But then something else appeared. For a moment, the signals became more complex, not less. As the surface ice vaporized, the spectrum lit up with chemicals we do not understand, molecules that have no business forming in such a simple cold object. It was as if the sun's heat was not just a force of destruction, but a key, a catalyst, an engine. Was it activating something? Was it starting a chemical reaction that was dormant for eons? We saw for just an instant the kind of chemical complexity that we associate with life. We must be careful. This is not proof. It is just a question. A deep, new, and terrifyingly beautiful question. In the end, this moment, this fiery pass by our star, it did not give us a clear answer. There is no headline that says we found it. There is no simple solution that we can package and close. This event was not a discovery. It was a witnessing. We are like ancient astronomers standing on a dark hill watching a new star blaze to life in the sky. We do not understand what it is. We have no name for it, but we know that we have seen it. We have witnessed an event that changes the map of what is possible. The mystery of Oumuamua has only deepened. It has used our own sun as a lamp, and in that brief, intense light it has shown us, not its identity, but the true depth of its own riddle. It showed us that the universe is far stranger, far more subtle than we have ever dared to imagine. And now, it is pulling away, it is already cooling. The show is over. It is racing back into the dark, heading for the deep, cold silence between the stars. It leaves our solar system forever. It leaves us changed. It leaves us with a profound, humbling sense of awe. It leaves us with more questions than we had when it arrived. And perhaps that is the greatest gift any visitor can bring. It reminds us to keep looking, to keep wondering, and to remain humble before the vast, silent ocean of the cosmos. It is now the middle of 2026. The frantic energy of discovery, the hurried calculations, the telescopes of the world locked on a single moving point. That time has passed. It feels like a dream we all shared. On the largest telescopes, the ones capable of seeing the faintest whispers of light are interstellar. Visitor, the Object 3I Atlas, is now just a handful of fading pixels. It has crossed the orbit of Saturn and then Uranus, and is now falling away from our Sun at tens of kilometers every second. It is rapidly retreating, a guest making a long, slow exit, returning to the vast dark hallway of interstellar space. The front door of our solar system is closing, and the object is on the other side on its way back to the cold and the dark. The world's attention has moved on, the news cycles are full of other things, of terrestrial concerns. But for those who watched, and for those of us who look up at the night sky, a profound change has settled in our hearts. So after all that, what did we truly learn? The truth is 3I Atlas left us with more questions than answers. It remains perhaps forever an enigma. We gathered an astonishing amount of data. We measured its light. We tracked its speed. We saw how it tumbled, how it reflected the sun's rays in a way that spoke of a strange, complex shape. And then there was the acceleration, that gentle, inexplicable push. It was not the wide, beautiful tail of a comet venting ice and dust. It was quieter, more mysterious. Was it a thin, invisible veil of hydrogen ice burning off in a way we had never seen before? Was it a strange interaction with the sun's magnetic fields? Was it a structure so thin, a cosmic sail just micrometers thick, that the simple pressure of sunlight was enough to move it? Our computers are still running the simulations. Our brightest minds are still debating in quiet, respectful tones. The data was extraordinary, but a final single conclusion. It did not arrive. There is no consensus. There is no paper that begins with the words, "We have solved it." Instead, 3I Atlas became a mirror. Every scientist, every dreamer projected onto it their own theories. It was for a time whatever we needed it to be. A fragment of a planet shattered billions of years ago. A natural object so bizarre it defied our neat categories. Or something else. The word was whispered but never proven. And in the end it did not matter. The object did not stop to explain itself, it did not pause. It simply continued on its ancient path, a path that happened to intersect with ours for one brief, brilliant moment in time. And as you lie here listening, feeling the pull of sleep, perhaps you can feel a connection to this. In our daily lives, we are surrounded by questions that demand answers. Our minds race trying to solve the puzzles of the day, to find a conclusion for every worry, to file away every problem neatly. But the universe in its vast wisdom teaches us something different. It teaches us that some things are simply beyond our knowing. The Object Atlas gave us a gift. It gave us the gift of mystery. It gave us permission to simply wonder. Just as that object is now letting go of our sun, pulling away into the quiet dark, you too can let go. You can release the need to have every answer. You can let the questions of your day fade just as Atlas is fading from our view. They can wait until tomorrow. Tonight you are allowed to simply exist, to drift. That final lingering question remains. The object has left taking its secrets with it. And we are still here. We are left on this small blue world under the same canopy of stars, but changed. We are left with ourselves, with our own introspection. Its passage was a cosmic interruption. It broke the routine of our solar system, the predictable orbits of our 9 planets. And in doing so, it broke our routine too. It forced us to lift our heads from our small screens and our immediate worries and to look up, to look out. For a few short months, humanity was united. Not in fear, but in profound shared curiosity. We were all, for a moment, a single species gazing at a traveller, wondering where it came from and where it was going. We were a family gathered on the porch of our tiny world, watching a stranger walk down the long, dusty road that passes by our home. And that is the final thought. That is the new understanding it left behind. Before this visitor, interstellar space was a concept. It was the theoretical empty blackness between the stars. We felt isolated. We believed we were an island, a self-contained system. But the existence of 3i, Atlas, whatever its nature, proved that we are not isolated at all. The void is not empty. It is an ecosystem. It is a cosmic ocean, and things drift between the stars. Matter flows. Dust, ice and rock forged in the fires of one star can after millions of years find themselves falling towards another. We are not alone in the sense that we are not separate. We are part of a vast, interconnected galactic environment. An environment where material and perhaps even stories flow between the stellar shores. Our little solar system is not a fortress, it is a harbour, and we just witnessed a ship from a far-off land pass through our waters. As the object Atlas continues its journey, it carries nothing of ours with it, except perhaps the reflected light of our sun. It moves back into the great silence. It will drift for thousands, perhaps millions of years in the cold, peaceful dark before it ever feels the warmth of another star. And as it journeys into that endless quiet night, perhaps we too can find our own quiet darkness. The soft, welcoming darkness of the room, the gentle, peaceful drift of our own minds letting go. Feel your own breath slowing. Feel the weight of the day lifting. You are part of this cosmic ecosystem. You are made of the same stardust that drifts between the worlds. You are safe, and it is time to rest, to drift, to sleep.